The new project verification feature allows a user to verify multiple toolpaths and connection moves for tool and shank gouges, tool holder collisions, and machine tool collisions, along with any connection moves, all in the click of one button. So we can do this by adding in any amount of toolpaths to an NC program. We can create varying NC programs, splitting up the amount of toolpaths we have. We can verify all NC programs at once by right-clicking on NC programs and choosing Verify All. We can right-click on a single NC program and verify that by itself, or we can select multiple NC programs and verify those selected ones. So to demonstrate this new functionality, I'm going to right-click on the NC program called Verify. This contains my 3 toolpaths, and I'm going to click Verify. This will bring up a new NC program verification dialog, and within this I choose what I want to verify and what I want to verify against. So first of all, I can choose which NC program I'm verifying. I'm then told what machine tool is being used to check for collisions, and I'm also told the position of the model. In this dialog, I can choose a machine tool clearance value. So I'm just going to enter 5mm. I can select or deselect to verify my toolpaths. So these toolpaths may have been verified before when we calculated. I can choose to re-verify them all, where I am overriding their initial holder and shank clearance if I choose to. So if I wanted to re-verify them so that they all have the same holder or shank clearance, for example, a holder clearance of 1, a shank clearance of 0.5, I can then choose to increase the toolpath clearances to match my new clearances here. Alternately, I can choose to verify the toolpaths again, but this time I want to keep the existing toolpath clearances. And then the final option I have is to verify any connecting moves. So I'm going to choose to verify both toolpaths and machine tool collisions. And then once I'm happy with my choices, I can just click Verify. So you can see now that PowerMill is running through each toolpath in the NC program. It is checking for tool collisions and gouges, tool holder collisions, and machine tool collisions. It is also checking to make sure that the machine tool is staying within its limits. So now that the verification is finished, I'm shown a list of all issues found. So I'm going to have to start going through these. I can easily click an issue, double click on it, and PowerMill will tell me what type of issue it is. So it is now saying that the machine tool could not reach a position. So if I click OK, I can open up my machine tool position form with this button here, or from my machine tool toolbar. So once I open that up, I can clearly see that I'm getting a warning message to say that the machine tool tried to reach a position outside of its limits. So now I know what the exact problem is. I can go and try and rectify it. So for this particular model, I can see that I can just reposition it on the table of my machine tool, and then hopefully the machine tool will be able to reach its limits then. So to reposition it, all I have to do is to alter the work plane which the model sits on. So the work plane is model location. If I open up my work plane editor, I have a number of editing options available to me. However, I'm just going to type in a known coordinate where I want the model and the work plane to move to. So that is 25, 0, 0. Hit enter, and the model moves with the work plane to that new position. So I can accept those changes, close my machine tool position form. I'm going to right click on the NC program, clear the verification, and then I'm going to verify again. Okay, so I can see my list has been massively reduced just by making that change to the work plane position. However, I still have some issues with my toolpaths. So the next issue I'm going to look at is tool gouges the model. So if I double click on this issue, PowerMill will snap the machine tool to where the issue was found. So I can just close that dialog. If I turn on my NC program, I can see that the gouge is taking place along a connecting move. So again, this is a problem that I'm going to have to fix as a user. So I think that I may have set my start and end points incorrectly. So if I open up the start and end point form, go to endpoint, and instead of using the last point, I'm going to use the last point safe. So if I apply and accept that, I now have a safe point above the previous end position of the toolpath. And if I go back into my verification form and re-verify, that issue is no longer a problem. But I still have a few left. So if I double click on the next issue which I want to look at and load it up, I get a PowerMill warning, a collision has been detected, and then the machine tool will snap to where that issue was found. So if I just close my project verification, I can see that the machine tool is colliding with the model in this position here. So I obviously need to change the orientation of the machine tool to avoid this collision. I can easily achieve this by opening up the dynamic machine control toolbar. So if I right click on my tool, go to Tool, Dynamic Machine Control, the toolbar opens up and I'm now given some options to alter the orientation of the machine tool. So I'm just going to tilt and rotate that until I'm happy that it will be collision free for this toolpath. So just a quick check, I can grab the tool, I can snap it to the model and the toolpath position points. I can see that there are no longer any collisions. So all I have to do now is update the toolpath. I'm going to accept those changes. And then I'm going to open up my verification form and re-verify the NC program. So this time, after checking all toolpaths and connecting moves, I can see that it is fully verified and there are no issues found. So I get a green tick here, and if I close that, my NC program now has a green tick also. You may notice that the toolpaths no longer have a green tick. The tick is now a kind of blue shade. All this signifies is that the NC program takes precedence in full verification over the toolpaths. So the toolpaths will no longer have a green tick. Only the NC program will have a green tick, because this signifies that all checks have been made. So in summary, project verification is a huge improvement in the effectiveness of gouge and collision checking all aspects of a toolpath and of an NC program, including connecting moves. So all collisions between the tool holder, the machine tool, and then gouges against the model for toolpaths are completely checked in one click using project verification.